Now that we demonstrated how to simulate the rolling of a six-sided die, we have a version of the example that's going to do that 6 million times. And of course, if random numbers are being generated properly, we would expect that we'll get approximately 1 million of each face. So 1 million ones, twos, threes, fours, fives, and sixes. So for the purpose of this example, we have once again just a main method in our class called roll die. We create the random numbers object of type random, and we're using the default seeding, which is based on the time, so that every time we run the program, we get a different set of results. And we have counters in this program, frequency 1 through 6, which will keep track of how many times we rolled each face. And we'll use a switch statement to help increment the appropriate counter. Once again, we declared a variable called face where we store the result of each calculation. And we have a for loop that's going to iterate 6 million times in this case. And for each iteration of the loop, we'll produce a number from 1 through 6 by calling the next method of our random numbers object. Then we'll use that face to increment one of the frequency counters that you see here. And finally, when we complete the loop, we will then display the values of each of those frequency counters. So if I go ahead and run this program, we'll see that we get each one approximately 1 million times. So we're a little bit above 1 million, a little bit below, a little bit above, a little bit below, a little bit below, and a little bit above once again. If I run the program again, we'll get different results, but once again, they'll all be relatively close to 1 million each time. I'll run it one more time just to demonstrate once again. And you see that the values once again have changed, but they're all within range of 1 million.